Perimembranous ventricular septal defect, though the commonest form of ventricular septal defect, is not that amenable to device closure of VSD. This is because the VSD in case of perimembranous location is close to the aortic valve, tricuspid valve, and the conduction system is there on the posterior margin of the perimembranous VSD. For these reasons, closing with a device, and for that matter with the surgical closure also there is a risk, is more likely to produce conduction disturbances and aortic valve injury. So that is why it is not that popular. Still, there are some devices which have been developed known as asymmetric VSD closure device for perimembranous VSD. As the name implies, this is an asymmetric device. This is the right ventricular disc which is symmetric, and this is the waist of about 1.5 millimeter thickness between the two discs, and this is the asymmetric portion. Towards the apex, the flange is about 5 millimeters, while towards the aorta, where impinging on the aortic valve is likely, the flange is only 0.5 millimeter. In this region it is 5 millimeter. Towards the aorta, the flange is only 0.5 millimeter. This picture or diagram is not on scale, only for explaining the concept. So, as the flange towards the aortic side is lesser, the chance for damage to the aortic valve and the conduction system is lesser for asymmetric VSD closure device. Usually for device closure, devices will have symmetric flanges on either sides. Here it is an asymmetric VSD closure device. This has been used in several reports and with reasonable results, though even now it is still an off-label use of the device. The right ventricular disc is 4 mm larger than the waist. The asymmetric VSD closure device is made of nitinol mesh covered with dacron fabric to facilitate thrombogenesis, so that the final occlusion of the defect is by thrombus formation in the mesh. Complete heart block has an important potential risk of device closure of perimembranous ventricular septal defect. This is because of pressure from the device damaging the atrioventricular conduction system, which passes along the posterior border of the VSD. Other possibilities are trauma during the implant procedure, leading to local hematoma formation and inflammatory response to the material of the device. Other potential complications include device migration, pericardial effusion, embolic episodes, delayed onset of conduction disturbance, or even infective endocarditis. Fortunately, these complications are rare. As with other intracardiac device closures, subjects are started on aspirin to prevent thrombus formation on the device, which is continued for 6 months, which is the period required for endothelialization of the device surface.